All right, my dear children, we will be moving now to the next topic related to this nuclear structure, that is nuclear size. Nuclear what size? Now, Rutherford experiment on alpha particle, scattering of a particle, is very, very important. Okay, very, very important, because this experiment not only give the discovery of nucleus, this experiment also measure the size of the nucleus. The size of the what? Nucleus. And then size of the nucleus is actually measured in terms of the radius of the nucleus. The radius of the nucleus. That's why Rutherford experiment on the alpha particle scattering experiment by what? A thin metallic foil provided a rough estimate of the size of the atomic nucleus. And that atomic nucleus size, rough estimate size, is nearly 10 minus 15 meters. See, I told you in the last video also. And this is the rough estimate size of the what? Size of the what? Atomic nucleus. Okay. Now, many scattering experiment using energetic electrons and neutrons as the scattering particle has been performed to determine the size of the nucleus. And this experiment show that the volume of the nucleus, see, the volume of the nucleus is directly proportional to the number of nucleons in it. And you know, you learned in the last video, nucleons means what? Proton and neutrons. And these protons and neutrons, which are the particles, are not same for all the nucleus of an atom. Okay, now all the nucleus of an atom. Different nucleus of an atom consist of different number of protons and neutrons. Okay, so these nucleons and nucleons comprises a certain volume. So the volume of the nucleus is actually directly proportional to the number of nucleons present in it. Which means the volume of a nucleus is directly proportional, as I said, to the number of nucleons present in it. And number of nucleons means, children, what is it? That is called what number? Mass number. I have already told you, mass number is the number of nucleons, means the total number of protons and neutrons present inside the what? Nucleus. So as for the experimental observation, okay, or scattering experiment performed, okay, for the nucleus, discovery of nucleus, and even to measure the size of the nucleus, as I said, the volume of the nucleus is directly proportional to the number of nucleons present in it. And number of nucleons means simply called what number? Mass number. So A is the symbol we use for what number? Mass number. Okay, what number? Mass number. And it is considered that every nucleus are basically what in shape? Spherical in shape. So assuming that the nucleus is almost what in shape? Spherical in shape. And you know every sphere has a volume. And the volume of the sphere is given by 4 by 3 pi r cube. 4 by 3 pi r cube. That means the volume of a nucleus, okay, is directly proportional to what number? Mass number. Mass number. Now, as I said, volume is expressed by 4 by 3 pi. Okay, let me write r cube. And this r, capital R, actually indicate the radius. This is the radius of the nucleus. Okay. And this relation which we have written, measure the volume of nucleus, is equals to the volume of the sphere. Because it was assumed that nucleus is usually what in shape? Spherical in shape. It's proportional to the mass number, as you know, it is symbolized by the A. Okay, so if r by 4 by 3 pi r cube is proportional to A, so in the relation this 4 by 3 pi is basically constant. This is basically what? Constant. Okay, now which means even if I write r cube is proportional to just cross multiplying this quantity, okay, 3 by 4 pi, okay, 4 pi A. So if I cross multiply, so this 3 will go in the numerator and 4 pi will go in the denominator. This relation says that even if I write this way, r cube is proportional to what? A only, because this is simply a constant. So writing this quantity, okay, let me just write, okay, directly, let me just write directly, okay, r cube is proportional to A, because this constant, when I use the sign proportional, children, when I use the sign proportional, this constant will be removed. That's why let me just not write this 4 by 3 by 4 pi. So even if you write with the variable where r is the radius which is varying, it can be of any radius for different nuclei, and A with the at mass number, it can be any mass number for different nuclei, which means r cube is proportional to A. See, if r cube is proportional to A, then r is proportional to A 1 by 3. Because even you remove cube from the left hand side, On the other hand, it will be cube root. Cube root means 1 by 3, which means the radius of the nucleus is proportional to cube root of the what number? Mass number. So if R is proportional to A 1 by 3, then you know there is a proportion. We can remove proportional sign to what sign? Equals to sign. And when you remove proportional sign to equals to sign, you have to put some constant. And we write that constant as R naught with A 1 by 3. So in the relation, if you see, this R naught is basically a constant. And we call this constant also as empirical constant. Empirical what? Constant. So empirical constant means a constant based on experiment. This value of constant based on the experiment and the size. Okay. And this value of R naught, which is a constant called empirical constant, has a rough value, which is a rough value, and this value was taken as 1.2 into the minus 15 meter. So the empirical constant, almost for all the what? For all the what nucleus of an atom is found to be approximately 1.2 into minus 15 meter. But this constant R naught is called what constant? Empirical constant. That's why to measure the radius of any nucleus of an atom, we can be measured by the relation R equals to R naught 8 to the power 1 by 3. Provided that this mass number are not same for all the atom, because different mass atom and different mass number, that's why they have different radius. Okay, that's why we can make a conclusion out here. The mass number A is different for different atoms. That's why the nuclei of different atoms have different radii. So I can just write a point out here that nuclei of different atoms, okay, nuclei of what? Different atoms have what? Different what? Radii. Different radii. Means the radius of all the atoms are not same. Different radius, nucleus have different radius. Okay, but the same relation now can be written in this way also. R equals, now instead of R naught, I write on 1.2 into minus 15, and I write on A to the 1 by 3 meter. Now this radius, when we calculate by using this value and subtracting this R naught this way, we measure this radius in meter. But the power, you can see 10 to the minus 15, okay, with meter is also equals to 1 for me. 1 for me. This also equals to 1 for me. And we can write even by F. Even we can write by what? F. The for me you can write as what? F. Which means the radius we can measure directly in terms of for me also. By the value 1.2 A 1 by 3 F. So this relation measure the radius in meter, and this relation measure the radius directly in what? F. F means the for me. F means what? For me. Means we can measure the radius directly into a 1 for me, or directly in for me. So it is given by 1.2 A 1 by 3 F. So thus we can understand that the nuclei of different atoms are different radii. That means the size of all the nucleus of different atoms are not same. But the radius of any nucleus of an atom can be measured by this formula. We can measure either in terms of meter, either we can measure in what? For me. But more the nucleus or more the mass number, more the radius. Okay, more the nucleons, number of nucleons present in the nucleus means more the mass number means more the radius. So this measures the nucleus size of an atom. Now other than this nuclear size, there is a nuclear what? Shape also. Now nuclear shape, as you come to know that the shape of the nucleus of all the atom was almost considered to be spherical. So that's why for almost all purposes, nuclei are considered as spherical in shape. Certain nuclei, however, deviate from sphericity. Okay, but this deviation is very, very less. That means very, very less. That means we consider the shape of the nucleus almost as spherical in shape. So it is assumed. It is assumed that the nucleus shape is almost what in shape? Spherical in shape. That's why the nucleus shape is almost considered as what in shape? Spherical in shape. Almost considered as what in shape? Spherical in shape. Spherical in shape. That's why in order to measure the radius, we use the formula volume of sphere. that is 4 by 3 pi r cube. Okay. Similarly, the nucleus has a density also, and density means mass by volume. We can measure the mass of the nucleus, measure the mass of the nucleus, and we can we know the volume of nucleus. Volume means the volume of the sphere. So with that we can measure the density of the nucleus. Okay, we can measure the density of nucleus, and density also determines whether more the number of nucleons present inside the nucleus means the nucleus has more density, because the number of nucleons present inside the nucleus determine whether the nucleus is heavy or light, because density means the heaviness or lightness of the particle or lightness of a body. So this makes the nucleus size, the shape, and just briefing with the nuclear density. Now in the next YouTube video we actually measure, we talk about the atomic masses and the unit that is used to measure the mass of the subatomic particle by a unit called atomic mass unit.